I think we've heard about technology today, we've heard about innovation, we've heard about collaboration, working together. I'm going to add aerospace to that. By aerospace, I mean technologies that we put on aircraft, civil aircraft mainly, and everything that goes into manufacturing those. Before I get started, though, I'd be really interested to hear who's working already in the aerospace sector in the room. Brilliant, sort of 30%. And is there anybody who's considering maybe moving into the aerospace sector but working in adjacent sectors at the moment? No, okay, maybe I can entice some of you. There we go. So this is me, indeed, Head of Innovation and Sustainability for the Aerospace Technology Institute. I'll tell you a little bit about the ATI, what it is, what we do. I'll tell you a bit about the decarbonization pathways that aerospace might take. We don't have a crystal ball. Nobody knows exactly how it's going to go, but there are a couple of pieces of the puzzle that have to go together. And I'll talk you through those. I'll talk a little bit about the technology challenges that need to be overcome in order to get there, and also the type of support that is available from us and from others as well. But I'll focus a little bit on the ATI, what kind of support you can get from us and how to work with us. So a little bit, who has heard actually of the ATI, the Aerospace Technology Institute, so far? Okay, brilliant, good, sort of half the room. So I won't dwell too long on this, but we've been around for about 10 years. We are part government funded, part industry funded, not for profit, to develop the strategy for the UK aerospace sector. As I said, civil aircraft, largely all of the parts, components, technologies that go on that and that go into manufacturing that. And our mission is really to advance the UK aerospace ecosystem and to make the sector competitive, economically competitive and sustainable, because we really think that has to be going hand in hand more and more over the next decade, and we'll look at how and why. In terms of our scope, if you look at that central circle there, that's the scope of technologies that we fund. So in terms of our core mission, we are a funder. We work with governments, so we work with the Department for Business and Trade and with Innovate UK to award grant funding for collaborative R&D projects that advance technologies from TRL 3 to 6. And we fund technologies that are in that center circle. We also have an underpinning strategy. So the question when you have funding is, well, how do you award the funding? What's the underpinning reasoning behind who gets what kind of funding? And so we then look at both the direction that these technologies take and where we think the sector is headed, should be headed. And then the concentric circles around that are a bit where we develop thought leadership, influencing and understanding sort of where the whole sector is moving, because obviously you can't produce aircraft unless you have the fuels and the infrastructure to support those aircraft technologies. It was really interesting to hear earlier about that company. I hadn't come across them yet, so that's an interesting new take. I hope I can engage with them moving forward. But so you look at fuels and energy, airports, airspace, and then operational improvements. So if we look at all of that, there are these 4 central statements that I'll go through in my presentation, and that I'll talk through with you. If you've got any questions, I hope you'll ask me on the panel later, or I'll be around as well a little bit. So we think there are pathways to decarbonizing the sector. There are multiple pathways, and you see different types of roadmaps, but in effect we have several things that have to come together, and there are pathways, but we think there are still key technology challenges that need to be overcome. It's not just challenges, though. That transition that is ahead of this sector, which is one of the hardest to decarbonize, and other sectors as well, offers significant opportunities. So there are market opportunities for jobs, skills across the country that we think the sector is moving into, and that we really want to make sure that everybody can leverage. The successful transformation of the sector, we think, really needs to include both new fuels and new technologies. So sometimes when you look into this space, you sometimes hear strong proponents of SAFs, of sustainable aviation fuels, and replacing the fuels. And sometimes you hear strong proponents of hydrogen and just building it all from scratch. But actually, it is really a mix of both. And the tricky bit is that it will all require innovation and development and investment in infrastructure and so on. But that's also the exciting bit, and that's also the opportunity, because there are a lot of new technologies and new opportunities in the sector. And then I'll hopefully leave you with a sense that there is opportunity in the sector and that there is also support. And the ATI is one of the organizations who can support you with that. So first bit, there are pathways, but there are also technological challenges that we need to overcome. The long and short of this slide, I'm not going to dwell on a lot of the detail, but the long and short is we think the sector is going to continue to grow as it has been growing over the last decades. In order to decarbonize with that growth, there are a couple of things that need to come together, or a number of things that need to come together. And so if you look at those slices that are going to work down our carbon emissions effectively, we start with ultra-efficient technologies. And this is everything that will make existing and future aircrafts more efficient. So lightweighting, propulsion improvements, everything that will apply to any kind of aircraft will benefit both conventional fleet and future fleet. And so we need to do everything that we can to help aircraft burn less fuel, because the less fuel we use, the less fuel we have to put on an aircraft, the less fuel we have to produce. So across the life cycle, that's one of the key things that we need to do. Then we're looking at the introduction of zero carbon technologies, and I'll talk a little bit about what those are and what the different options are, and especially what the two main options are when we're looking at larger aircraft. We also need operational improvements, and we really need to step those up. So over the last decades, there have been operational improvement of sort of 1% or so, all the time, continuous improvement, but we need to at least double those operational efficiencies, if not quadruple them, in order to get to where we need to be. So even that kind of continuous improvement really requires innovation. Then we have a big slice of waste-based fuels, so sustainable aviation fuels produced from biomass, primarily from waste. In the UK, the sustainable aviation kind of guidance from government has just come out, the consultation, and that's going to basically focus only on waste-based sustainable aviation fuels, which is good because that way you don't replace crops. But because we're looking at waste, that is limited in terms of how it can scale, because hopefully we'll be producing less and less waste, and it's a limited resource anyway. And so you can't scale that to the degree that is required to supply the aviation fuel that we expect will be needed in the future. So what we need then is that turquoise slice, which is alternative fuels and or other measures. And the alternative other fuels are basically synthetic SAFs, so synthetically produced sustainable aviation fuels. If none of that means anything to you, don't worry, I'll explain it in a minute. But just to give you an overview of sort of the different slices that really need to come together. Another challenge that we need to overcome, and that industry is starting to look at more and more, there's just a research program that has been launched, a 10 million research program, and the ATI is also looking at the industrial side of this, is the non-CO2 emissions. So obviously we're all talking about CO2 emissions, very important, critical. The summary of this research, this is, sorry about not putting the source, this is research by Professor David Lee, is that potentially the non-CO2 emissions, so the NOx, the sulfur, the soot, and the water that is emitted from kerosene is potentially higher, so the NOx impact may be higher than the CO2 impact in itself. So it really is an area that requires urgent attention. To date, we don't know exactly. The gray bands are the bands of uncertainty. So there's really high uncertainty in terms of how big the impact of non-CO2 emissions is, but we do know it is significant, and we do know it needs to be addressed. And industry is really, we're all pulling up our socks and working on it. So that's good news, but there is technology challenge, and there is research, fundamental research that needs to be done in order to really crack that. So what that means, if you think back to that concentric circle diagram, what that means is across all of the things that the aerospace sector focuses on, across all of the areas that the ATI focuses on, we need to really accelerate and drive innovation, and hopefully that presents plenty of innovation opportunities for you in the room and for some of your peers in the Silverstone Technology Cluster. So it is tricky, it is a challenge, it is in a way really fascinating because we know what we need to do. So as with maybe some other innovations in the past, where innovation was disruptive often and organic, but it wasn't necessarily that vision of this is where we need to get to, we only know where we need to get to, this is the objective, this is what we need to do. It's a different take on a really big innovation challenge, but it's also a huge opportunity. And the opportunity is potentially a 4.3 trillion market, billion, a 4.3 billion market over the next aggregate years up to 2050. And if you look at this, we really expect growth in the sector to continue. However, if you look at the conventional segment, so the gray segment, that's not going to continue growing. So the growth is really coming from the innovation, from the new technologies, from the ultra-efficient aircraft, from the smaller AAM, so the advanced air mobility segment, and from the zero carbon segment, so the more efficient or zero carbon emitting technologies. And so that's really where the future of the sector lies, we think, and that's where the opportunity for businesses like yours lies. It's not just about the market. What does the market mean? The market means jobs, the market means GDP for the UK, it means skills, it means apprenticeships. So it's really a key sector for the UK, and we want to make sure that the leadership that the aerospace sector has had in the UK can continue, and that we can build onto existing skills, onto existing businesses, existing jobs, people really working in this advanced and comparatively well-paying sector across the country, that we can continue to build on this strength and develop the jobs and the skills required for the future. So what does that mean in terms of technologies, technology transformation, technology development, technology opportunities? Firstly, where do we think we need to focus in terms of decarbonizing and reaping the economic opportunity? There is a lot of opportunity in this whole sector, and you've seen the different slices in the market. But really, if you look at it from a market and from a carbon emissions perspective, upward of 90% of the market are larger aircraft, so wide body, mid-size and narrow body, and also upward of 90% of the CO2 emissions are also produced by larger aircraft. So that means that in order to decarbonize and in order to drive that economic competitiveness, we should really focus on the larger aircraft. Doesn't mean that the rest isn't relevant as well, and we think especially there might be some technology developments that can then transition to larger aircraft. But we do really need to focus on that larger segment primarily. In terms of fuels, there are a lot of different fuels. This is a slide that confuses me every time I look at it, but I'm going to try and talk through it with you, so hopefully it won't be confusing at the end of it. There are a lot of different options that we have investigated. We finished a project a little while ago, the Fly Zero project, that was sort of a spin out of the ATI, a feasibility study with 100 secondees from across the sector, looking at what could be the most viable fuel for aerospace for the future. And they looked at all of these different fuels and at the pros and cons of each of those fuels. What I find really helpful about this slide is that it really summarizes why we're looking, as I'll tell you in a minute, primarily at liquid hydrogen at the moment and at SAF. So batteries, great, don't produce any emissions. They're too heavy for larger aircraft. They work for drones, potentially for sort of the smaller AAM segment, a few people. But at the moment, and also for the foreseeable future, we think the energy density in batteries won't actually scale to the amount that's needed and also to the level that you need to power them up for liftoff and landing to allow a servicing of larger aircraft. So unfortunately for that segment that we're looking at, we don't at the moment see a pathway over the next decades. I will jump to ammonia, which basically has, you can see at the red dots basically are kind of the knockout factors, but it has really high non-CO2 emissions, and as we've seen, if you offset CO2 emissions with non-CO2 emissions, you're not necessarily actually addressing the problem. So unfortunately, for aviation, ammonia is not currently, we think, an option. Also the mass, there's a problem in terms of compressing enough, so the energy density, how do you get enough of that fuel onto an aircraft? What we've landed basically with is liquid hydrogen combustion as opposed to gaseous and fuel cells. Why? Sort of as a really interesting area, not that these two others, they're also interesting for other applications, but for larger aircraft less so. Fuel cells at the moment can't scale in terms of mass, propulsion mass. to the larger aircraft. Again, kind of the weight of the fuel cell at the moment won't scale to that. And then gaseous hydrogen, we've heard earlier, I thought that was really fascinating, can't actually be condensed enough. So the amount of space, not weight, but space that you would need if you transport the gaseous hydrogen on an aircraft just kind of won't work in terms of the physics of an airplane. In terms of liquid hydrogen, you condense it, you cool it down to minus 253 degrees, and you can actually put enough on an aircraft to get around the globe with one stop. So that is looking quite promising. We think there are still barriers in terms of infrastructure, and then you actually need to develop new technologies on the aircraft itself, because you can't just like replace the combustion. You have to replace everything. You have to move the tanks, for one, from the wings into the belly of the aircraft, which is a huge change, and many others. But in terms of the performance of the aircraft and the reach, we think that's a good. That's a really interesting option moving forward. And then you've got SAFs, which still burn, so it's not like they don't emit, but they absorb through their life cycle, and we'll look at that in a minute. But we think the fuel cost of that at the moment is a difficult topic. So, benefits, challenges of SAF. Who has not heard about sustainable aviation fuels yet? Nobody. Who's really confident that they know how sustainable aviation fuels work? Okay, a few. So I will talk about this for a minute. So you've heard about them. Basically, they are an alternative to SAF, CAF, conventional aviation fuels, kerosene. They are still fuels that you put in the aircraft or any other engine. In this case, obviously, we're speaking about aircraft, and you burn them. So that they still produce CO2 emissions and the end, non-CO2 emissions, but they are absorbed throughout their life cycle. So it's a net zero. It's not a zero emissions. It's a net zero proposition. They are interesting because you can, to a degree, replace existing fuels with sustainable aviation fuels without very big technology adjustments. The more sustainable aviation fuels you put in an aircraft, so you can mix them to a degree with kerosene, but the more your percentage of the sustainable fuel is, the more you might need to make some adjustments on the aircraft system. But in essence, you can still continue using existing or very similar aircraft architectures with sustainable aviation fuels, and you get to a sort of upwards of 40% savings, which is what the current government consultation is proposing. So any fuel that is compliant and that saves at least 40% of CO2 emissions would be classed as a sustainable aviation fuel. The problem is with scalability, as I said earlier, and hence the PTL SAF. So this is a synthetic version of that that is produced and can be scaled in theory. In theory, if we have enough energy, can be scaled more radically. But the problem with that is the cost, because you need hydrogen and you need carbon capture. And that's where you get into the question of SAF versus hydrogen. So if you need hydrogen to produce sustainable aviation fuels, it might make more sense because it's much more energy efficient to actually use the hydrogen itself, which then leads to the technologies that need to then be developed. So in order for an aircraft to be able to actually burn hydrogen, you have a whole host of new technologies. And I think if you're working in this space, this is one slide that I would encourage you to take away and look at the technology opportunities in this space in terms of what needs to be developed for aircraft to be able to use hydrogen as a new fuel. And we think that would actually allow us a trip around the globe, as I said, with one stop. So, a couple of words about the support. I've got about 2 minutes left. If you have more questions, please find me or my colleague Martin, who's sitting over there after this, and have a chat. So the ATI is supporting the sector. I've talked a bit about our technology strategy and roadmaps that underpin what we do as an organization and also what we fund. We have 2 funding programs. We've just launched an SME-specific funding program recently, so if you're interested in that, either of those, please do go to our website. There's a special funding section. It has a lot of detail about eligibility criteria, the process, how you can apply. You can apply. We do encourage collaborative applications to really make sure that technologies can be exploited across the sector. So collaborations will be great, but you can also apply as a single business. It needs to align with our strategy, which you will also find on our website, and which is a little bit, I've summarized a little bit earlier. We also have a complementary program, which is actually what I'm leading and what I'm sort of here as a representative of today, the ATI Hub. So even if you're not interested in funding or not currently interested in funding, we have technology clinics, we have workshops, we have showcases and boot camps. We have a lot of other opportunities for you to come and get engaged with us, get engaged with peers in the sector across the country. We're really looking to bring together the advanced aerospace ecosystem, so innovators that are looking into the future of the aerospace sector. So if you're one of those either driving that already or interested in moving into this space, please do come and find us. Look at our webpage. It's ATI, I think I've got it somewhere here, ati.org.uk, and then /hub is this complementary initiative to the funding. Do find us, do engage with us. We're really eager to speak to you. And just to summarize, so no doubt it's a big challenge. It's not going to happen on its own, and that roadmap is a vision of the future, but it's not going to happen without all of us actually working on it and accelerating that innovation and the adoption of those technologies. It's also a huge opportunity for all of you, or many of you, hopefully, for the sector, for the country, and for the global community. There is technology development and there are technology opportunities, and we need every single one of you who could be contributing their skills and their kind of business expertise to this, to reach out and to connect with us and with others across the sector. And I'll be really excited to speak to you and see what role you might be playing in that future transformation. Thank you.